10. Inductors. Part 3. The inductor itself. An inductor is essentially a coil of wire with an iron core. They store energy in a magnetic field. The symbol for the inductor is like this. That indicates a coil. What do inductors do? Consider this circuit here. What will happen when the switch is closed? That switch there. Lamp A will glow immediately. This one will glow immediately. Lamp B will take some time to reach full brightness. That lamp B here, because of this inductor here. Now we'll look at why an inductor behaves the way it does. As the current starts to flow through the inductor, a magnetic field starts to form around it. As this field forms, the magnetic field lines cut through the coils in the inductor and induce a voltage across the inductor. According to Lenz's law, this induced voltage will oppose the voltage that caused it. Continuing with the question why, this opposing induced voltage restricts the current built up in the circuit, so it takes a while for the bulb to reach full brightness. Put that one there. Inductors again. Once the current has reached its full value, it is no longer changing, so the field lines in the inductor are no longer building up. It has reached its maximum. So there is no induced back EMF or the opposing voltage we were talking about. It's just another name for it. The inductor has no effect on the circuit any longer. Inductance. The effect of an inductor in the circuit is measured as inductance, L. The changing current produces a changing field, which produces a changing flux. Phi is flux. So flux is proportional to current. The constant of proportionality is the inductance L. To change from that to that, we introduce this inductance L. So flux is equal to L times the current. This is Faraday's law that we looked at in a previous video. And if we replace phi, which is a flux, with L times I, then the formula simplifies down to that. Inductance again. The size of the induced opposing voltage or back EMF depends on the inductance of the inductor and the rate of change of current. The unit for inductance is Henry, capital H. Take special note, an inductor only affects circuits when the current is changing and will always oppose what's happening.